to get started off with, chlorine dioxide is a gas. Don't let anyone fool you that it's a liquid, that there is such a thing as stabilized chlorine dioxide, because chlorine dioxide is anything but stable, at least in the gas form. However, it is very soluble in water, even more so than chlorine. It can off-gas depending on the concentration that it is created at, so you have to be aware of that. And the solution is actually stable for a few days, so that's why it's used a lot in vegetable and fruit washing, because it lasts a little bit longer than chlorine does and does not leave any taste or odor concerns. So it's good for those type applications. You can detect the odor at under 2 ppm, so it does give off an odor, and it can be an irritant above 4.5 ppm. So when flume washers for vegetable or fruits are washing on the flumes, they have to be very careful that it's vented, depending on the concentration of the chlorine dioxide that they are using to disinfect their fruits or vegetables. We see here from the chlorine dioxide molecule that there is an unpaired electron, which is a free radical, and as a result, that leads to the instability of chlorine dioxide as a gas, as ClO2. However, we know that in our business, the ClO2 is in an aqueous form at certain concentrations. It is much more stable, depending on the concentration, and therefore it is safe to use for the markets that we intend to use it for. One big thing to remember is that it is not pH dependent like chlorine is. So pH is from 5 to 10. Chlorine dioxide is still the same, whereas with chlorine you have a problem. Also, the chlorine dioxide molecule is much smaller than chlorine, so it's able to penetrate cellular membranes. Excuse me. Better than chlorine, better than chloramines, better than some of the other disinfection methods out there. And so as a result, it's able to kill and destroy something that's really a problem in our area of water and wastewater treatment, and that is biofilm. Chlorine dioxide only reacts as an oxidant. It does not chlorinate, even though it has chlorine in the name. The method that we're going to use, which I'll talk about here shortly, does not use chlorine in the process as a bleach or a gas. So as a result, it does not chlorinate. As a result, it does not form any THMs, also known as trihalomethanes, for example, chloroform. It does not have any formation of chlorophenols. And this is important in the wine industry because TCPs, trichlorophenols, trichloroanisols, tribromoanisols are a problem in the wine industry for cork taint and must and mold. As a result of that, chlorine dioxide does not form any of those. It does not react with ammonia, and it doesn't have any lingering taste or odor concerns if you're using it for such things as washing of fruits or vegetables or washing out containers that wine is going to go into. One thing you do have to be aware of when sizing a chlorine dioxide unit is that it does react with iron and manganese, as well as some nitrates and sulfides, but the two main culprits here are iron and manganese. So before we size up a chlorine dioxide unit for any application, it could be a winery, it could be a hospital, it could be a rendering plant, it could be a number of different things in the applications that we use it for, we have to know the water analysis to make sure that there's not too much iron or manganese that's going to consume chlorine dioxide. You can see from this slide that 1 milligram of iron consumes 1.2 milligrams of chlorine dioxide, where manganese, it actually consumes 2.5 milligrams of chlorine dioxide. And one thing you don't want to do is undersize your unit, so these have to be taken into consideration when sizing up a chlorine dioxide generator. You can see from this slide that even at a low dose of chlorine dioxide, and we're talking about 0.3 ppm here, that after only 5 minutes of contact time with any type of species such as E. coli or harmful yeast or pediococcus, that it is virtually eliminated after 5 minutes, certainly up around 10-minute time. And this is, once again, only 0.3 ppm, where if we're talking about chlorine or some other disinfectants, you're talking about quite a bit more in the ppm range, and other problems that are there because of those different disinfection methods. Here you can see that, once again, just a low amount of ppm of chlorine dioxide can do some damage to E. coli and some other pseudomonas here in 60 seconds, or certainly within 5-minute time. You can see the log inactivation that chlorine dioxide does. It is a wonderful disinfectant and really does a great job on some of these to reduce bacteria. Fungicides are the same. Once again, just a low amount of chlorine dioxide. Once again, if we're talking about chlorine, we could be talking up into the 50 ppm, 100 ppm, and this is getting really kind of dangerous to be using high levels of chlorine like that because of the odor, the problems with lingering taste, and just using up a lot of chemical at that point in time. So right now we'll talk about our chlorine dioxide technology. We have sold over 8,000 generators worldwide since the inception of chlorine dioxide for Prominent, which I think was around the 70s, late 70s, early 80s. That's quite a bit. Prominent, unlike some of the other competition we have out there, we use a two-step method. And those steps are using the addition of sodium chloride and hydrochloric acid in a reaction chamber. You can see from the equation here, stoichiometric equation, we're taking 4 moles of hydrochloric acid, mixing it with 5 moles of sodium chloride, which results in 4 moles of chlorine dioxide, plus some residuals of salt and water. Our yields, which, if you look at the yield of 5 chlorides to 4 sodium hydroxides, that's an 80% yield. However, our generation methods can go up above 85, and I've seen them up into the mid-90s already. And I've had some chem vendors do some analysis, and we were up in the mid-90s. So our generators are very accurate due to our metering pumps and the technology of our system, and so we can hit those high yields. Once again, this is a chlorine-free solution of chlorine dioxide, and that's really important if you're talking in the food and beverage industry, specifically wineries, because as I mentioned earlier, chlorine can cause trichloroanissols, trichlorophenols, tribromoanissols, which are a problem to the wine industry, but our method of generation does not have any chlorine in it at all. Some of the byproducts you'll see with chlorine dioxide are chlorite and chlorate. And as you see from the stoichiometric equation, they're not a byproduct of the actual formation of chlorine dioxide. They become byproducts when there's other species in the water that the chlorine dioxide reacts with, and then thereby you might get chlorites or chlorates. Once again, we don't have to handle any chlorine or liquid bleach or chlorine gas, and chlorine dioxide does not react with any bromides, but chlorine and ozone do. Here's a photo of one of our more widely used units. This is the CDVC photo. You can see there's 2 metering pumps which put in accurate amounts of chlorite and acid. You have a bypass water system. Sorry about that, hold on. Bypass water system, which is regulated in the PLC, as well as the pumps are regulated. And inside is a reactor, and I'll show you what the reactor looks like here shortly. Static mixer, where the water mixes with the chlorine dioxide solution, and then out into your process at whatever predetermined part per million residual you decide upon. This particular unit, which uses dilute chemicals, and we'll talk in a bit here about the dilute chemicals, we can go from our smallest unit, which is 20 grams per hour, up to 2,000 grams per hour. And also please note the pressure here. As the units get larger, the amount of operating pressure that we have to go against is decreased. So if you have a higher operating pressure than 29, maybe that larger unit isn't what you need to do your disinfection. If we take a look at, a lot of people in our industry talk about pounds per day of chlorine dioxide. So a 600 gram per hour unit would give you about 31 pounds per day. And a 2,000 gram unit is the biggest of the CDV series, would give us about 106 pounds per day. In order to calculate the size of the generator you would need, a typical calculation, now this doesn't take into consideration the iron and manganese we talked about earlier, but you would take your flow rate in gallons per minute, and multiply that by your ppm residual that you want to have for your process. It could be half a ppm, could be 1 ppm, could be 5 ppm. You divide that by a constant of 4.4, and that gives you grams per hour. So an example calculation would be 100 gallons per minute multiplied by 0.5 residual, 0.5 ppm residual of chlorine dioxide, divided by 4.4, and that gives you a generator size of 11.4 grams per hour. So it just kind of gives you a ballpark idea of what size generator you would need. Once again, you need to take into consideration the water chemistry and a few other factors before you actually get a definite size of unit that you would want. For our CDV series to operate, as I mentioned, we use 2 precursor chemicals. These are diluted. These are sodium chlorite at 7.5% and hydrochloric acid at 9%. These are available through chemical vendors. Sometimes not as easy as the concentrated chemicals because these have to be diluted by the chem vendor, but they are available. Once again, no chlorine added. We take a look at what this unit would actually generate. If you take 1 liter of sodium chlorite and mix it with 1 liter of HCl, you will get 40 grams of chlorine dioxide. And there's a few conditions for you to look at, like temperature and pressure. This is what the unit actually consists of. 2 metering pumps, which give you the exact amounts of the precursor chemicals fed into a reactor. Now, this reactor is only an aqueous phase. There is no gas or only gas in this reactor. It is mixed with a water solution, which creates an aqueous solution of chlorine dioxide at 2% or 20,000 ppm. Under pressure, that solution then goes, there's a back pressure valve here. It's mixed in with your bypass water. The bypass water is regulated by the PLC, so if the water slows down, the whole process slows down. If the water increases, then the pumps increase, and everything is kept in a very stoichiometric equation here. There's a static mixer that helps also to mix the chlorine dioxide solution with the water and then out into your process. So very simple. There are quite a few safety factors in here that if one of the containers of the chloride or the acid go dry, the system shuts down. If something happens to one of the metering pumps, the system shuts down. If the bypass water would stop, the system would shut down. There's quite a few safety factors because with something like chlorine dioxide, you just want to make sure that everything is safe. You also want to make sure that your operators do not mix the chloride and the acid except what's going on in the generator, because mixed together they will create chlorine dioxide gas, which can be explosive. This is actually the concentrations you're getting out of the unit. As I mentioned earlier, you get a 2% or 20,000 ppm solution out of the generator in the reactor. Once it's mixed with the bypass water, you can get up anywhere from 200 to 1,000 ppm solution of chlorine dioxide. That's all regulated by the PLC. That can either go into your process or go into a day tank. And basically what you want to feed in your application might be anywhere from 0.05 to 2 ppm of chlorine dioxide. And that could be for washing tanks, washing wine casks or kegs. That could be treating water, treating wastewater. Could be a number of things going on, but you can regulate how much you want to use for your application. This is the inside of the reactor. As I mentioned, a 2% solution inside. There are mixing beads inside to help mix the chlorine dioxide gas with the water solution to create a 2% solution. Once again, there is no gas phase in here. Everything is an aqueous solution. If you need more of an output of chlorine dioxide, we have a system called a CDK. Now this uses concentrated chemicals, and they are sodium chloride at 25% and hydrochloric acid at 30%. So the design is if you have 1 liter of the chloride plus 1 liter of the HCl, that gives you 150 grams of ClO2. If you remember a couple of slides back, the CDV gave you only 40 grams of ClO2. So once again, this is a much higher output system. This is a photo of the CDK. Notice there is another panel to the left, which is a dilution panel. This goes up to 12,000 grams per hour of output, and this is our biggest system. We had a question earlier today about a system that was about 3 times this size, and my answer to that is that this is as big as we make. I have seen applications where we've taken 2 or 3 of these units and chained them together to get a higher output, but the prominent expertise is in the smaller output range, not necessarily the larger ranges you get on some of these systems that might use chlorine gas or possibly the purate method, which we'll talk about in a little bit here, which can create a lot more output of chlorine dioxide. We also have a CDLB for smaller applications. This particular unit could be for smaller wineries or hospitals or hotels, healthcare facilities where you really don't need a lot of output. This system is based on 2 precursor feed pumps and actually chlorine dioxide solution injection pump. This system actually makes a solution which is in a tank, a small tank behind this unit, which you can't see, and then that is fed by this third pump into your process. The CDLB uses dilute chemicals, which are the same as the CDV series, and you see we go from 6 to 120 grams per hour with the CDLB. Once again, a smaller unit can be used for smaller applications. It would be a less expensive unit than the CDV or the CDK, so it might be better for a smaller application than the larger ones. We also have a new chlorine dioxide generator coming out very shortly. We're currently working on all the marketing tools so we can launch this probably sometime in April or maybe May. It's called the CDEA, and it is a less expensive version of the CDV that you saw earlier. It uses, once again, 2 metering pumps. It does have a reactor, bypass water, but the PLC is not as kind of high output as the CDV. It's more of like a D1C model that we have. So it basically eliminated some of the bells and whistles you would have on the CDV, but this is a unit that you could easily use to get into applications or markets where the other offerings of prominent are maybe just a little bit too much cost for that particular customer. So this would be a less expensive model. I don't have pricing for you yet. We'll have that in the next month or 2, but I just wanted you to be aware of this. It uses dilute chemicals, and the output is from a maximum of 45 up to 140 grams per hour. So it fits in well between the CDLB and the CDV. However, it's going to be less expensive due to it's pretty much a bare bones unit with not a lot of output. However, it is a safe unit, and we'll get into more of that when we do the launch on this new CDEA. If you want to measure, which I hope you do, the chlorine dioxide residual or the chlorite residual, we do have controllers and sensors to do that. The D1CB and the DAC will both measure our chlorine dioxide as chlorine dioxide, not using ORP. And we can also measure chlorite. We're one of the few manufacturers of a chlorite sensor that actually measures the chlorite residual. We also have a photometer to do testing if you wanted to take a grab sample and do your calibration of your chlorine dioxide generator and your D1C controller. It's called the DT4, and it not only measures chlorine dioxide, but it will also measure chlorite. So you can double check what the sensor's reading. Here's an example of some of our sensors. We have chlorine dioxide sensors for clean water. We have sensors for water that has surfactant in it, and also sensors for dirty water. Now, these are all membrane sensors, so you have to be careful on the amount of dirty water that you're passing through. And we also have 2 versions available, or a version available for the chlorite as well, up to 2 ppm. So let's talk now about some other generation methods that are out there. There's a method for sodium chlorite and chlorine gas. Once again, what we talked about and why we like the prominent generators is in this particular method, you're adding chlorine into the process. So you have a chance to form trihalomethanes, other disinfection products, of course, trichlorophenols, which is, as we talked earlier, bad for the wine industry, specifically because of the cork taint and mold that is formed through chlorine and sometimes bromine. With this method, you have to store chlorine gas, which I know a lot of people are trying to get away from, but this method was really used to generate large volumes of chlorine dioxide, and actually still is today. A second method is using sodium chlorite, hydrochloric acid, and sodium hypochlorite, or bleach. Once again, you're adding chlorine into the process. Some people say that the chlorine helps drive the equation to the right so you get a higher yield, but as I mentioned, we're getting up to above 85 and even up into the mid-90s with our process, so really no need to use a three-chemical method. Once again, you have a chance for disinfection byproducts, and you have to purchase 3 chemicals as opposed to 2. Some people like to call their solution stabilized chlorine dioxide. This is basically a buffered sodium chloride solution, which is a weaker alternative to the chlorine dioxide solution that we generate with our method. There really isn't such thing as stabilized chlorine dioxide because we talked about earlier, chlorine dioxide is a gas and is not stable. So a stabilized chlorine dioxide solution is most likely nothing more than just a buffered sodium chloride solution. There are also chlorine dioxide sachets or tea bags out there that people just put into a 5-gallon pail or a gallon of water. These, of course, are affected by impurities in the water. They're only good for specific quantities of water and ppm concentration. And we have heard instances that these can explode if not tended to properly. Typically, you get a tea bag which has a known concentration, put it in the water, and it gives you what they say might be a 5 ppm concentration. It's not adjustable unless you dilute it down. You certainly couldn't increase it unless you drop in another tea bag, and then your suspect is what you really have. So, not a very good form of use of chlorine dioxide. There's also a method called the purate method. This uses sodium chlorate. Make note of the chlorate, not chlorite. Uses sulfuric acid and also hydrogen peroxide. It's been known to be good for large quantities of chlorine dioxide, and typically it can be expensive because you're buying 3 chemicals, and the generator is expensive because it has to all be consisted of PVDF piping and generation reactors because of the sulfuric acid. There's also an electrochemical method, and that generates chlorine dioxide on site. Typically, they need pure water to work, so you have to do a pre-filter before you even get it into the system. It does give you undesired byproducts, such as hydrogen, which can be explosive, and caustic, which you have to somehow get rid of. Maintenance can be high because there's a lot to this system. Replacing a cell can be expensive. If you don't treat your water properly incoming, then the cell is going to have a shorter life than it would be if you had clean water coming in. So there's a lot to be concerned about. Plus, these systems can be very expensive upfront for capital costs. Some of the competition that we typically see, Grundfos, which is similar to some of their offerings are similar to what PFC has. Nelco has Halox. Diversey has their own version. I don't recall what they call it. Ashland's system is called Generox. Pureline is an on-site version. Sabre has 2 and 3 chemical systems. DuPont has also several type systems, and they're also they have the stabilized because they purchased IDI several years ago, and they're the ones that touted the stabilized chlorine dioxide. Ecolab recently bought the Purate from AkzoNobel. There's another system called dripping wet water, which I believe only uses 1 chemical. Siemens, Wallace & Tiernan, and Severn Trent have both been around for a very long time and make several type systems, but the majority of their systems were with chlorine gas. So some applications in the wine industry. We've used our generators in the wine industry for treating well water, feed water, wash water, as well as cooling water and the actual process water. It's been used for clean in place along with acid and caustic. It's been used for filter cleaning. It's been used for wastewater. And the majority of the applications we've seen are for tank or barrel cleaning, and also for the indoor and outdoor tank farms. Now, one of the things we've also seen that works very well is when cleaning the outside of tanks is a foaming process. If the chlorine dioxide solution is just the basic water solution and is sprayed onto an outside tank, you may see specific areas of cleaning and areas maybe where it really didn't penetrate some of the molds and things that get on the outside of these outdoor tanks. But we found out that with foaming, that the foam actually takes a long time and drips down the tank and thereby does a better job of cleaning. So keep that in mind if you're looking for applications for outdoor tank farms. It doesn't have to be the wine industry. It could be really any industry that uses these tanks and want to keep them clean. That foaming is a good idea, and you can do that with chlorine dioxide as part of the foaming process. Here's a schematic of a bottle washing with chlorine dioxide. This is actually rinsing outside and inside bottles, and this can be used for the wine industry, for the brewer industry, for bottled water, for mixed drinks, soft drinks, fruit drinks, anything that's out there. And as I mentioned, chlorine dioxide is a great disinfectant, and it lingers around for a while. Of course, you'd want to rewash it, the chlorine dioxide, before it goes into your process, but the chlorine dioxide does a great job of disinfection. For bottle rinsing, this would be when you would wash the outside, the inside of the bottles only. Once again, chlorine dioxide is used to rinse the inside, as we did with the bottle washing process. CIP is used along with hot water, acid, and caustic. Chlorine dioxide could be used in a couple of different places to do CIP. And once again, if some of these piping systems that you see in these applications, and there's always a chance of biofilm being formed in older piping systems and dead legs. And, biofilm could possibly come Legionella, that if you have a little bit of chlorine dioxide in your water system, it will completely eliminate the biofilm after time, depending on how bad the biofilm is. And we've seen piping systems completely clogged with biofilm. The chlorine dioxide will do a great job of keeping the biofilm from coming back once it's eliminated. Here's an example of a filling machine. Now this just, I didn't have a picture of a wine bottling, but this is a beer bottling. During this process of filling, product gets spilled, bottles explode, caps come off, and you're left with your product on these machines. And in order to keep bacteria and other things from forming, a lot of these machines are rinsed off every once in a while with the chlorine dioxide solution. This would, once again, kill all the bacteria, yeast, molds, anything else that would form from product spills and keep things running clean. And when you're working with food products, you want to make sure that that's for surely that it's being done. A particular application that we had in the wine industry, this particular winery was using bleach or sodium hypochlorite to clean aging and storage tanks. They started to have a concern about trichloroanissols, which, as I mentioned earlier, cause cork taint and must and mold in wine. This particular winery tested chlorine dioxide and PAA. The PAA proved to be too expensive, so the ClO2 was chosen for CIP tank washing and also the filter cleaning. They also decided to use chlorine dioxide to treat their cooling towers. And they had day tanks that were made with 1,000 ppm solutions of chlorine dioxide. And then they used the Venturi to inject the chlorine dioxide into wine tanks for cleaning. So a great application. There's many more out there. This was just one of the ones that I chose to go through with you. If you need more instances of applications, I have those available. So in conclusion for today, chlorine dioxide is the best choice for disinfection and sanitization for the wine industry. And one of the big things is that it's chlorine-free. It's a strong disinfectant, which must be generated on site. It eliminates biofilms and other harmful bacteria. It will not form trichloroanisole or tribromoanisole compounds, which are typically seen in the wine industry. Safe for operators to use with some precautions. Not expensive to operate once you can get up through the capital costs of buying a generator. It can save you water and money, and it's a very versatile answer or solution to other competitive products. So, as I mentioned earlier, we have a new chlorine dioxide generator coming out that could fit well in the wine industry and other small market industries, the CDEA, and we will have more on that. Stay tuned in April or May. In the meantime, you can visit our website, www.prominent.us, or visit www.wineriesbystate.com to find a winery near you so you can call on them and sell a Prominent chlorine dioxide generator. So I thank you for your time, and I'll turn it back on to Jim and any questions you might have.
Hey, thanks again, everyone, for spending some time. Ken's presentation here focused a lot on the wine industry, but there are a lot of different applications that we've gotten into with our chlorine dioxide generators. You know, anything from the CDLBs, where they're big in hospitals and senior care facilities. The CDVCs, they were big in the in depending on the size of the winery. But remember that CDLB could also fit into smaller wineries. So the CDKs, we've had very good success in some rendering plant applications to get rid of the smells, and they work very, very well for us. So, you know, we hope that just to name a few applications, you know, just the wineries alone, if you were on for last week's presentation, Ken mentioned there are several thousand wineries in the United States alone, and they're in all 50 states now. So there are definitely opportunities out there. You know, once these larger wineries that we've gotten into start doing that, the smaller wineries kind of catch on to that technology, and they're going to be looking for some of those answers. So here we do have some questions coming in. For those of you who have questions and would like answers, please use the questions section in the GoToWebinar toolbar, and we will try to answer those as they come to us. The first question is, when you say dilute, I thought this was a gas.
Chlorine dioxide, ClO2, is a gas. However, chlorine dioxide is a gas, is not used for any application because it is a dangerous species. So in our generator, the chlorine dioxide gas is mixed with water to form an aqueous solution, a 2% solution in the reactor, and then that is diluted further down to different concentrations depending on what you're using for your process. It could be 200 ppm, and then you can dilute that down further to, say, half a ppm or whatever. But chlorine dioxide as a molecule is a gas, but it is never used in that state. It is used as a solution.
Another question we have here, are there wastewater discharge regulations on chlorine dioxide?
Yes, there is. Off the top of my head, there's one for chlorine dioxide and one for chloride. One is 1 ppm and the other is 0.8 ppm. And this was from Tom. I'm not sure exactly which is which, but it's one of the two. But yes, there are EPA regulations for wastewater.
So yeah, be sure to check with your state. That might be different from state to state too. Having a request for liquid 55 gallon, and I am confused. I thought this was a gas which needed to be mixed.
I don't know. A liquid 55 gallon, I don't know what that means. I mean, you can buy, as I mentioned, the stabilized chlorine dioxide, but basically what you're getting is a sodium chloride solution. So our process of using chlorine dioxide has to be generated on site. So if you have an application in a winery, let's say, you would have to purchase a permanent dioxide generator and the two precursor chemicals and generate on site what you need to do your disinfection. You can make a solution and store it in a day tank as long as it's a weaker solution. You certainly couldn't put a 20,000 ppm solution into a tank because that will off gas. But a diluted solution will stay in solution for a couple of days, which you can use to meter off into your application at a smaller application, or a smaller part per million concentration.
So keep in mind, Prominent does offer tanks. We can color code the tanks for the precursors, as well as we can offer a tank to have the made-up solution of chlorine dioxide at a certain concentration for you, and then a pump to pump it into the process at whatever concentration you might need. So depending on your flow rate needed, and some of them aren't really the instantaneous. With the CDLBs, we can make those into a tank, and you can size it off of your average usage instead of your instantaneous maximum in some cases. So we can talk a little bit more about that. Another question we have here, would this not be the best solution for all food and beverage applications?
Carla, you are 100% correct. The problem that I've fought in my 18 years here at Prominent is trying to get people to understand that. What I talked about last week when I talked about chlorine or sodium hypochlorite is that it's so widely used and people are so comfortable and familiar with it that they're not even concerned about THMs or trichloroanisols or trichlorophenols. All they know is that I buy it in a 55-gallon drum, I need a metering pump, and it seems to work. And it does work to a certain extent. But when you're talking about washing vegetables or washing fruits or rinsing insides of bottles, chlorine dioxide is by far a better solution. A lot of people are afraid of chlorine dioxide. It's not, wow, chlorine dioxide sounds like explosive, or it sounds dangerous or whatever. And it can be, but it doesn't have to be. It can be very safe. And we use it in a lot of applications. They even use it in swimming pools. I mean, how bad can it be? But yes, it would be the best solution. Our job is to get out there and talk to people. I've already done seminars up and down the state of California for wineries and other engineering firms. And if any of you can pull something together in your territory, I'd be glad to come down and do a chlorine dioxide seminar for you. No problems.
Yeah, Ken has a lot of the experience with all of those applications we mentioned. Anything from the hospitals, the senior care facilities, the rendering plants, wineries. He's been a big asset to us, getting us into a lot of those wineries with the help of the West Coast out there. So, again, anything we can do to help you, please let us know. We are having some added input here. Thank you, Fred. Fred is saying, I think this is referring to that wastewater discharge regulation. Fred is saying that chlorite is 1 part per million and 0.8 ppm is the chlorine dioxide. So hopefully that will help you. We have another question here. In swimming pools, hydroxan is sometimes used. Is this stabilized form of chlorine dioxide?
I am not familiar with hydroxan. I know in swimming pools, I've seen applications where they use the on-site version, where they're generating the chlorine dioxide on site using salt. But I know that over in Europe, they have used chlorine dioxide for swimming pools, and it's not necessarily that they're putting the chlorine dioxide into the swimming pool of the surface, but they're using it to clean filters and other equipment for the pool industry to keep it free of the biofilm, which once again is an issue.
Yeah, from what I remember hearing from, I think it was Bob Capel telling me, or telling a group that I was part of, for swimming pools, I don't know that chlorine dioxide is approved here in the States yet. However, Disney is funding some studies to use that. When there is an accident in the pool, a biological accident in the pool, they actually have to close that pool for a period of time. And when I say pool, that's an attraction in a park, whether it be a water slide or some sort of lazy river or whatever it is. If there is an accident there, they have to close that for a period of time. They have to treat it with a very high dosage of chlorine for that set period of time before they can reopen it. So while that ride is down, of course, all of the consumers in that park are upset. It's one less thing that they have to take advantage of. So Disney is funding a study because chlorine dioxide is such a good disinfectant that they can cut that time that attraction is closed significantly. So Disney, with a lot of funds, I should say, is trying to push for that. So hopefully that will be something that is approved in a short period of time.